This example is another example where we know some population parameter. In this case, we're going to know the population mean. Every year when I teach this course, I have a goal of having the average of the class be approximately a B. Some years average grades are a little below B, some years a little higher, and I have to be able to assess whether I've made my goal of having the class average be approximately a B. Let's look at some numbers that from a recent semester. My goal here is that everybody get that the average for the course be approximately a B. So my known population parameter is 80. One semester, the average grade was 78. And some might argue that we didn't make our goal of getting the average grade to an 80 and we failed to meet that particular goal. My contention as a statistician is that that could be due to sampling error, and that we may have been close enough to have that class average be statistically indistinguishable from my goal of creating a class where people get an average of a B. The standard deviation that particular year, the standard deviation was approximately 10.5, and I had 63 students in total. I'm going to set my alpha value equal to 0.05, and I'm going to do a two-tailed test because I'm not making a prediction a priori that the average is higher or lower, just that it's within approximately within that range of 80. My t statistic with 63 degrees of freedom is approximately 2. I'm going to draw a picture to help explain what it is we're trying to actually do here. This will be a picture of our sampling distribution. We know that our sampling distribution is approximately normally distributed and that the population mean is 80, which again is the target value that we're looking at. Somewhere up in this part of the distribution is a number that cuts off the top 2.5% of the distribution. So if I were to draw a line here, I know that over here I would have 0.025 of the distribution. And equivalently, somewhere down here, I could draw a line and I would have 0.025 as well. And that would leave 95% in the middle of the distribution in this shaded in area over here. 5% in the tails in total, 95% in the middle of the distribution. I can figure out what these two unknown values are by doing a little bit of math. Let's go ahead and look at our z-score. Our z-score is equal to our population mean minus our sample mean divided by the standard error of the sampling distribution. Well, I know that if I move plus or minus 1.96 standard deviation units, that is if my z-score is equal to 1.96, then I get to the place where I cut off the middle 95% of this distribution. What I would need to do is take this formula and solve for the difference in the numerator. So I can do a little algebra here, and I can get my difference equal to a z-score times the standard error. I know that my z-score is 1.96, and I know that my standard error is going to be equal to 10.5 divided by the square root of 63. And that this is going to equal 1.96 times 1.32. When I solve for that, and I add that to 80, I find out I get an upper limit here of approximately 82.6 and a lower limit of approximately 77.4. That is to say, 95% of the sampling distribution falls between approximately 77.4 and 82.6, and approximately 5% lies outside those boundaries. We note that my score overall is 78, so it's below 80. It falls somewhere here, and therefore I will fail to reject the null hypothesis and conclude that while this class was below my target, it was not sufficiently below the target to indicate that we hadn't met our goal. It's within the bounds of what chance could produce. We can also solve this problem with a straight-ahead z-score problem, and I'll do that next. As a straight z-score problem, all I need to do is solve for z here and see if it's within plus or minus 2 as indicated by the number I got from the t-table. So going ahead and solving this problem, my numerator is 78 minus 80 over my standard error, which is 10.5 divided by the square root of 63, which is equal to minus 2 divided by 1.32, which is approximately equal to minus 1.51. Notice the negative number indicates that the average for this class was below my target, but for me to feel that we hadn't reached our goal, it would have to be the negative number would have to be minus 2 or greater. So again, I'm going to conclude that, as I did with the other way of solving the problem, that we were within the bounds of what chance could produce with a class of size 63, and that we achieved our goal of getting an average in this class of approximately 80%.